2, we still have 2 more sections after this, and we will take quite a bit of or 3 more sections. We'll take quite a bit of time because it's going to go through all the common functions, transformations, so a lot of graphing stuff. So we're going to do a quiz before we get into all of that. So your quiz tomorrow is sections 2.2 through 2.5. So that is circles, functions. So remember, looking at a graph, how do you know if it's a function from the graph? Vertical line test, evaluating functions, function notation. And then the majority of it will be things with lines. So writing the equations that we'll talk about today, graphing a line, domain, range, slope, that stuff that we've been doing. Your circles you might need to review. There'll be 2 questions on your quiz about circles. So remember with those circles, I might just say, right, the center, radius, form, and I think there's space on the back of this handout if you want to write this down, of a circle with center -3, 7, and radius 4. If you know what the equation of a circle looks like, this is a pretty easy question. If you don't, you're kind of in trouble. Do you guys remember the format? X minus h squared plus y minus k squared equals r squared. Okay, I don't care if you don't call it h and k, but you need to know that a circle looks like this. So it's x minus the x value of the vertex, which is, so minus the -3 would make it x plus 3 squared, plus y minus the y value of the vertex, so y minus 7 squared, equals r squared, so the radius squared, which would be 16. So, not a high point value question, you either have it or you don't, but easy if you know what your format looks like. The other type of question we had when we were dealing with circles was if I said, find the center and radius. And I told you the general equation. So if I said this is dangerous for me to just make this up. We'll see how that works out. What did we have to do to get a center and a radius from this?
Put them into the x's and the y's.
We put the x's together, left ourselves some room, put the y's together, left ourselves some room. What did we do with this 17? Right, and then remember we completed the square twice. So for each variable, to complete the square, that means you divide by 2 and square it. So -8 divided by 2 would be -4. Squared is 16. And if I add 16 to one side, we add it to the other. We do the same thing for our y's. So 10 divided by 2 squared. So that's 5 squared, which is 25. Add to both sides. And remember the whole point was so that these factored into perfect squares. So x squared breaks into x, it was a minus, square root of 16 is 4. This was a y plus 5. And over here we get 24. So now I have my equation, so we can get the center and the radius. What's the center of this circle? 4 and -5, because remember the equation itself had the minus in it, so it's always the opposite sign. The radius, we know that r squared is 24. So to find the radius, you have to square root 24. That would break into a 4 and a 6, so we would get 2 radical 6. Alright, so I wanted to review those. That was the very first section, and probably the new piece out of what we've done. Since then, talking about functions and lines, that stuff has been things that you've seen the past couple of years. So, any questions about circles or what will be on this quiz tomorrow? So, let's get through this section then, see what we remember. Tomorrow we'll grade our homework first, and then if there are any other questions that pop up after our homework, we'll definitely go over that. So, equations of lines. We have different options for writing it. So, point slope formula, remember in that x1, y1 represents a point on the line. X and y are just your variables, x, y. So, and it's always our slope. Slope-intercept form, y equals mx plus b, that's what we see when we're graphing all the time. The other form that we could see is standard form. We don't see it as much, but it does have its place, so you have to be able to turn things into standard form. And so that's when x and y are on the same side. Remember, in that, your coefficient of x has to be positive. You can't have fractions or decimals. When we write our equations, I do not care if you use the point slope formula or slope intercept, so it's kind of a personal preference. If I asked you to write the equation of the line going through the point 3, -5 with a slope of -2. So I'm going to look at this. Do you guys remember which of the two methods you used the most last year? Not really? I'll work on both and you guys tell me what you like. How about that? So in this would be my point, like x1, y1. So point slope is probably the more efficient, but it is another formula to remember. So it's y minus our y value. So y minus -5, make y plus 5, equals our slope, -2, x minus our x value, which is 3. Use this one. Okay. So we would have y plus 5 equals, if we distribute, that's -2x plus 6. If I'm writing it in slope-intercept form, all we have to do to finish is subtract over the 5. So we get -2x plus 1. Does that seem familiar? If you didn't use that formula, if you just want to use y equals mx plus b, all you do is you take your point, plug in for x and y so you can find your b. So the y is -5, slope is -2, x is 3 plus b. Add the 6 over, so y-intercept is 1. So mx plus b, -2x plus 1. So 2 methods, same equation at the end. I do not care how you get it. How many of you use the first method? Okay, how many do the second one? All right, so we're pretty 50-50 split here. So whatever you like is fine with these. Let's look at B. What would I have to do first here? Find our slope. Remember slope y2 minus y1 or x2 minus x1? Change in y over change in would be negative 4 minus 2 over 2 minus negative 3. So I get negative 6/5. Now I have to use this and one of my points to get my equation. Does it matter which point I pick? No. Equation of a line is the same no matter what. So if I just went with the first one, pick your favorite method. If you do point slope, you would have y minus 2 equals negative 6/5 x minus negative 3 or x plus 3. Finish, you add over the 2. So you get negative 6/5 x minus 6. Did you get the same thing if you directly did y equals mx plus b? You should, assuming all of our work is correct. I want to give you guys a chance to try one. Do we have any questions on that? So the next slide has one very similar. I want you to take a second and write the equation of that line. Go ahead and sketch a graph with it. So walking around, our process is good, but we're making a lot of errors as we go through it. Slope, change in y over change in x. So y2 minus y1 over x2 minus x1. So I get negative 2 over 4 or negative 1/2. Take one of your points, doesn't matter which one, and your slope. Either do point slope or plug in y equals mx plus b. I saw more people doing point slope, so I'll do that. So y minus 4 equals negative 1/2. X minus negative 2 makes x plus 2. So we get negative 1/2 x minus 1. Add over the 4. So negative 1/2 x plus 3. For graphing it, you could either plot your 2 points and draw a line between them, or start at 3. Slope is negative 1/2, so down 1 over 2. And we'll get the same line either way. All right, any questions on that one? Can you look at a graph and identify all the information? So I know that's not a huge graph on your paper, hopefully you can see it. If I want to find my slope, we need 2 points that we can tell exactly. So it looks like maybe 1, 1, 0, 3. So slope, rise over run, you go up 2 and backwards 1. So we should get a slope of negative 2. Intercept, so x-intercept, y-intercept. How do you find an x-intercept? Where it crosses the x-axis. What does that look like about? 1.5. If I wanted to write it as an ordered pair, what's my y value? 0. Y-intercept is where we cross the y-axis. What would that be? 0, 3. Okay, equation. Y equals mx plus b. We have all the stuff. M is negative 2. X. What's b? 3, the y-intercept. All right, so you should be able to look at a graph, tell me slope, x-intercept, y-intercept, and write an equation from it. Any questions there? Okay, so 2 more pieces that we have to talk about. Horizontal and vertical lines. And we talked about them in terms of slopes. We know a horizontal line looks like this. What did the equation look like? Y equals a number. So if it goes through a point AB, it's always y equals the y value of that point. So it would just be y equals b, whatever the y value is. A vertical line. So we know that's when slope is undefined. Equation is always x equals a number. What would this one have to equal? A, just the x value of the vertex. Which of those is a function? Horizontal. Why is vertical not? Right, it fails that vertical line test. Okay, now we have to think for a second. Think about on your grid, coordinate grid, the x-axis is a horizontal line. What would be the equation of the x-axis? Y equals 0. Y-axis is a vertical line. What's the equation of that vertical line? X equals 0. Good. All right. Any questions about horizontal and vertical? Parallel and perpendicular. What's parallel mean? Right. Railroad tracks. They never cross. So the only way that can be true is if their slopes are the same. Perpendicular means what? Right. You form, and when they cross, they form what kind of angle? 90 degrees. So the only way it can be an exact 90-degree angle is if they are opposite reciprocals. Okay, so that means one's positive and one's negative. Reciprocals, you flip it. So let's try a couple examples. I want the standard form of line. What's standard form? Ax plus by equals c. Of the line going through the point 3, 5 and parallel to the line y, or 2x plus 5y equals 4. So if it's parallel, we need to get our slope. So if we get y by itself, divide everything by 5. What does parallel tell me?
They have the
Same slope. Okay, so what is the slope of this line? Negative 2/5. So the line parallel to it will also have a slope of negative 2/5. We know our point, 3, 5, so then either plug into y equals mx plus b or your point slope form. So y minus 5 equals negative 2/5 x minus 3. So no matter which way we do it, we should get to this point. Y equals negative 2/5 x plus 31/5. Is that my final answer? What did I ask for? Standard form. Okay, we never go directly to standard form. We get slope intercept and then we put it in the form we need. Standard form says ax plus by equals c. So I need to move my x term over. Okay, x has to be positive, which it is, but we can't have any fractions. So what would I have to multiply by? You can have a coefficient, you just can't have a denominator. So we could just multiply everything by 5. So that would give me a 2x plus a 5y equals 31. So you just distribute that to every term. So all the fractions are eliminated. And again, the only reason I had to do that is because I specifically said give me the standard forms. Is that one okay? What is B asking for? It's perpendicular. Same line. So we know this line had a slope of -2/5. So if you're perpendicular, what would your slope be? Positive 5/2. Okay, I'm still going through the 0.35. I'm going to mix it up. I'll do y equals mx plus b for those of you that like it. My y is 5, slope 5 halves, x is 3. You can certainly do point slope instead here. All get to y equals 5 halves x minus 5 halves. How do I put that in standard form? Subtract over our 5 halves x. Okay, standard form, we have to have x and y on the same side. We can't have fractions, and x has to be positive. So what could I multiply everything by? So I get a positive 5x minus 2y equals 5. Are there any questions about writing our equations? Is this familiar, hopefully? Homework, I'm actually not doing those book problems. I typed up a handout and posted it on Classroom. So you don't have to have your textbook today. Look at the handout posted on Classroom.